Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to show you how to use molar mass in calculations. So let's get into this. So in this problem we're first asked to calculate the formula mass of sodium hydrogen carbonate. We need to know what that formula is. If you don't, I'll quickly show you how to do that. So even though we have it right here, I'll show you how we got this formula. So sodium hydrogen carbonate, the first thing you should notice that there's a metal and nonmetals here. So this is ionic. So you should be aware that there are ions here. The first ion is going to be the metal because that's positive. Everything else makes up the negative ion. And since we got hydrogen and carbonate here, that seems to indicate we have two elements. So that should tip you off that this is a polyatomic ion. So polyatomic ions, you just need to know the formulas and their charges. There's just no way around memorizing them. So here we have sodium. So you should know that Na has a positive 1 charge. And then hydrogen carbonate, you can figure that one out because if you know the carbonate ion, that's going to be CO3 with a 2 minus charge. And if you add a hydrogen to that, thinking of the hydrogen as being positive, right? Positive is going to eliminate one of the negatives and make it a -1. So if we add a hydrogen here, we can get rid of the 2, and then we got a -1 there. So that would be our hydrogen carbonate ion. And then look, we got a +1, -1, they cancel each other out. So you only need one each. So the formula is going to be Na, oops, NaHCO3. So now we can figure out what the formula mass is by adding up all of the ions, I'm sorry, not all of the atoms in the formula, and that'll give us the formula mass. So we're going to add that up together. So Na is 22. We got one of those. So 1 times 22.99 plus we're going to add the hydrogen. We got one of those. We're going to multiply that by 1.008. And we got one carbon, so we'll add a carbon. So 1 times 12.011. And then we'll add to that 3 oxygens. So we got 3 oxygens multiplied by 15.9994. And we add all that together, you get 84.0072. And that would be AMUs because we're asking for the formula mass. That is going to be the mass of one formula unit of this ionic compound. So that is the formula mass. Now we can go to part B. They ask, what is the mass in grams of 1 mole of this substance? Well, if you think about it, if you remember, here we have grams, mass in grams per 1 mole. Well, what does that sound like? That sounds like the definition of molar mass. The molar mass is the mass of 1 mole of a substance in grams, right? So the great thing about this is that the molar mass, the mass in grams of one unit of your substance in AMUs is the same number in grams for 1 mole. So all this is that the mass in grams, so 1 mole of this substance, NaHCO3, is equal to the same number but in grams. Oops. Sorry about that. So that's going to be 84.0072 grams of NaHCO3. And so that is the relationship between moles and mass for this substance. And that's the molar mass. And so next thing they ask us is write a conversion factor. Well, the conversion factor to help us convert between mass and moles of this substance is its molar mass. So all we need to do is take this, write it as a conversion factor. What is a conversion factor? It's just a ratio of two units that are related to each other that are equal, right? So here, since these are equal, all I have to do is set them over each other as a ratio. And there's two ways to do that. You can have moles on top, 1 mole of the NaHCO3 over the grams, 84.0072 grams of the NaHCO3. Or you could do it the other way. You could flip it. So you could put the 84.0072 grams of the sodium hydrogen carbonate, and then put the moles on the bottom. 1 mole of the sodium hydrogen carbonate on the bottom. So either one of those, or both of them, are conversion factors for converting between moles and grams. It just depends on which direction you're going. If you're converting from grams to moles, then you would want this one. If you're converting from moles to grams, then you want this one. So it just depends. So that brings us to the next problem here. So here they're asking us to actually convert something. So they want to know how many moles of the NaHCO3 are in 0.4 grams of this substance. So we're going to have to start with 0.4 grams of the sodium hydrogen carbonate over 1. And since they want moles, we got grams, so we just need to use molar mass as a conversion factor. So this is a one-step problem. So here I have grams on top. I want grams on the bottom of my conversion factor. So here I have grams on the bottom, so I'm going to put 84.0072 grams of the sodium hydrogen carbonate. And then I have 1 mole of the sodium hydrogen carbonate on top. So grams cancels out. I have moles on the top. That's what they want. I'm done. So all I need to do is multiply across the top, divide by what's on the bottom, and I get my answer. So let's get our answer. And I get 0.0476. I'm sorry, 0.00. So the answer is 0.00476 moles of my NaHCO3. Okay. But we need to pay attention to significant figures. Here we have 1 sig fig. Here we have 6. So the least number is 1. Our answer can only have has to have the same number of sig figs as the one with the least. So here we're looking at 1. So this should be rounded to 0.005 moles of the NaHCO3. So that is our final answer. And that, ladies and gentlemen, is it for this video. I hope you enjoyed this video. If you learned from this video, then by all means, please share this video, like this video, hit that like button. Also, subscribe to my channel, please. Make sure you hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you, except for spelling. Don't talk about my spelling. If you have a question you want me to answer, or a problem to solve, or a topic you want me to cover, I would love to do that for you. Thanks for joining me, and have a great day.